today from the Radiant Professionals Alliance, and welcome to this session of Hydronic Talk, which is a presentation of the Radiant Professionals Alliance. I am your host, Mark Etherton. I'm the Executive Director of the RPA, and I've been a member of this organization for the last 20 years. I'm also a contributing editor to Contractor Magazine and have been for about the last 14 years. And if you have nothing else better to do, I would suggest that you go online and read some of the articles I've been writing over the last year which pertain to alternative radiant panel systems. I love radiant floors, but there's a lot of other ways of being able to deliver good radiant comfort. And that information is all available online at contractormagazine.com or contractormag.com. I've been an educator for 38 years. I'm a former expert witness, have myself surrounded with lawyers. I am still an active licensed master plumber in the state of Colorado. Real quickly want to go over some rules of the road. If possible, please use headphones with a boom mic. Please mute your mic to avoid feedback and background noises. I'd like for you to enter your questions into the typing into the Q&A text box for me or my guest. And then any questions regarding the presentation will be responded to after the presentation unless you feel it's something very dire, in which case let me know in your message and I will interrupt our presenter and ask the question. Following the formal presentation, we will have a trade secrets session, which will follow the presentation that our guest is going to be doing. And I would like to thank everybody for taking time out of their busy schedule and coming in to attend this session. Here's an example of some alternative radiant panel systems that I've been developing over the last 20 years. This particular radiant panel job was done in a Habitat for Humanity house about 22 years ago. And the last word that I had from the service contractor was that it was still working fantastic. The system is basically a simple matter of putting the radiant panels into the walls and keeping them lower than the nail height that you typically use for nailing pictures, so everything is below 4 foot there, so we don't have to worry about people finding our tube for us. Here's a picture of the radiant ceiling project that I have in my house up in the mountains, and it works very well. I use this to dispel some myths. Everybody always says that heat rises, which we all know that it doesn't. Hot fluids rise, hot water, hot air. Radiant energy travels omnidirectionally, including downward, through the path of least resistance in an effort to basically balance out the mean radiant temperature of all the temperatures within that space. So I've actually got thermographic images showing the floor at 74 degrees Fahrenheit, which is warm enough to the point where you can walk around in your bare feet and not feel any discomfort at all. Here's the only advertisement you'll see on this show for the time being. I would like for anybody that's attending to join the Radiant Professionals Alliance. Our website is radiantprofessionalsalliance.org. The show runs every other week, and we interview guests varying from folks like Kurt and Rick in regards to their product, all the way up to people that really are involved within the industry but maybe not turning wrenches and stuff. As an example, Dan Holohan. Dan will be our next guest, and I'll show you where he comes in later on in these slides. Immediately after the formal presentation, we have an open Q&A session. And this Q&A session was originally intended for people to be able to bring problems that they don't seem to be able to resolve and allow all the people that are attending the session to give input to it and so we can find a solution. I know that a lot of people are afraid of making themselves look silly or stupid. And there's no such thing as a stupid question, just mistakes that are made when questions are not asked. So feel free to ask any questions that you have that we might possibly be able to help you with. This show is intended to be fun, educational, entertaining, and did I mention fun? Submit guest interviewee requests to me at mark.etherton@iapmo.org, which is our parent organization. Now let's jump into some hydronic news that you can use. The AHR Expo is coming up the last week in January, January 26th through the 28th, and it will be in Chicago. And we have a substantial program set up for education. We've actually got 6 different courses that we will be presenting that feature an update on what's going on with the Uniform Solar Energy and Hydronics Code, as well as the standards that are being developed for the certification of hydronic heating system designers and installers, and just a whole gamut of information that we have available to you. Each class is 2 hours in length, and there will be 3 on Monday and 3 on Wednesday. And if you pay the fee to get into the AHR show, these classes are free to you. So by all means, come and listen and see the people that we've got. We've got Bob Rohr, we've got Max Rohr, we have Dave Yates, we have Wes Cisco, we have a whole bunch of people. I mean, there's too many people for me to be able to mention in this short of a period of time, but it is a very, very good educational program. We will also be holding our annual meeting and our educational programs in conjunction with AHR 2015. And by all means, get involved. This is your chance to come in and express your concerns about the direction that this organization is headed. Our RPA University fall course offerings are currently available for anybody that's interested in signing up. By the way, these courses are going to be a prerequisite for being able to take the test for sitting for the exam for certification of designers and installers. So if you're thinking about it, definitely check these courses out and get them under your belt, and you'll feel much more comfortable when it comes time to take the exam. We have the Fundamentals of Radiant Design, which Dave Yates put together. Excellent course. He's got a lot of anecdotal information that he puts in there that you won't find anywhere else from someone with Dave's experience. We also have a course up there. It's a free lecture for 4 storage strategies for integrating solar and hydronic heating. These are put on by Von Woodruff. And he's also got a full-blown course on there, which I believe is an 8-week course, which is basically how to interface solar thermal into hydronic radiant heating and cooling systems. So by all means, get over to the website, which is the RPA University, and check it out. Here's our lawyer-required image disclaimer. The graphics and illustrations used in this webinar are presented for educational purposes only. RPA IAPMO does not endorse or recommend the vendor or product depicted, nor any vendor or product. RPA IAPMO makes no representations, warranties, or guarantees as to and assumes no responsibility for the products depicted, and RPA IAPMO expressly disclaims all liability for damages of any kind arising out of the use of the performance of vendors, products, or services depicted. Thank you, lawyers. Here I thought I was going to be getting away from them when I got out of the consulting business, and now I'm surrounded by them, but these are the good guys. So today's guest is Kurt Armstrong and Rick Caruso with the Swing Green team. And gentlemen, how are you this morning?
Oh, we're doing pretty good today. How are you doing?
I'm wonderful.
Great, Mark.
Good. I would like to thank both of you for taking the time to put this show together and come out and speak to our guests today. And Kurt, you now have power of the controls, so go ahead and take off and run us through your presentation.
Okay. Well, first off, I'd like to thank you for having us on the show again this morning. What we're going to do today is basically kind of introduce what our product is and how it works. And we're going to go through 2 different products today. One product is the drain water heat recovery, and the other one is the air conditioning heat recovery systems. Both systems basically recover waste heat that we normally throw away, either from hot drain water or air conditioning sewer heat. Anyhow, this is our agenda for today. We're going to introduce ourselves a little bit of where our company is. And are you getting a lot of static there?
I am.
Okay.
I'm not really sure why. It almost sounds like a loose connection or something.
Huh.
It could be a loose nut behind my keyboard.
Yeah, while I'm talking here, I'm getting a lot of static there, and I'm not quite sure what it is. Okay, anyhow, this is our agenda, and what we're going to do is, like I said, we're going to basically introduce ourselves, our company, and basically where we came from, and go over the drain water heat recovery, what it is, its applications, tests and certifications, and installation, and basically the same thing with the air conditioning heat recovery. And, of course, what everybody wants to know is, what's in it for me? As far as a contractor, end user, what the paybacks and benefits are. So let's get started here. So who is Swing Green? We're a small company located in Colorado. Springs. We've been in business as Swing Green since 2011, and it was formerly the GFX store, which is owned by Tina, who's the actual owner and president. And we're a small, disadvantaged, veteran-owned small business and a woman-owned small business. And for anybody that's interested, those are our DUNS and CAGE codes and other government numbers. And, of course, our affiliations down at the bottom. So, let's see. And this is our basic mission statement and what we want to do. And our mission is basically to provide clients with a product line that is both superior in quality and efficiency to other products in the market. We also believe in the exploration and innovations of technologies to provide increased efficiency of the energy we use. And our vision is through innovation. It is the vision of Swing Green to become a market leader in developing new energy-saving products that will decrease our clients' energy costs, consumption, and carbon footprints through the recycling of and reduction of energy use. And basically, we're looking for things in our product lines that make sense. We're not out there to reinvent the wheel, but we're looking to make better use of the energy that we have. Okay, what are heat recovery systems? Like I said earlier, simply put, drain and air conditioning heat recovery systems recover waste heat energy that would otherwise be thrown away. And waste heat from our hot drain water or AC compressor superheat is used to heat hot water. And what this really means is hot drain water that goes down the drains. All right, we've already paid to heat it. Why not use that heat energy to reheat the water coming back into the hot water heating system? And same thing with the air conditioning systems. All that hot air that's blown off into the atmosphere, that heat energy, we use that to produce hot water. Oh. Okay, drain water heat recovery systems. Swing Green's drain water heat recovery system is a simple way to save money, and they're very easy to install. They're recognized by several conservation organizations. They've been tested by the U.S. Department of Energy, and they're also recognized by the Green Builders Association LEED. There's ResNet points assigned to these. We'll go over that later. And a lot of state energy conservation programs provide tax credits as well as other benefits to installing these systems.
Kurt, I just wanted to come in here real quick. Had a really good conversation yesterday with Gary Klein, who's very involved in codes, authority with ResNet Energy. He works closely with ACEEE, Department of Energy, and is a leader and a pioneer that has been working and an advocate for drain water heat recovery. One of the things he said yesterday to me is with the new codes coming in 2015, whereas the contractors and most people in the past did not really talk about positive way or anything about drain water. IATMO has been they said very good things on it. But next year, what everybody's going to see, code people.
Rick, I can barely hear you.
Okay, Rick is going over a couple things there. Apparently his mic faded out, but he was talking over a number of the... No, cannot hear you. Come here. Here, I'll put him on my mic. But he was just talking about a number of the... no. It's faded right out.
Sorry about that. Didn't know it was going to be a comedy show. Anyways.
It'll be interesting and funny.
Yes. So anyways, had a conversation yesterday. Mark, I don't know if you know Gary Klein with ResNet.
Name sounds familiar, but I don't know him personally.
Gary, phenomenal phenomenal advocate for energy savings and drain water heat recovery. Yesterday, he explained to me next year, 2015's codes are going to actually be enabling and recommending as a energy savings, lead points, IAPMO endorsement for the drain water heat recovery and the superheaters, our air fox. And he said that in the past, codes, contractors stayed away from it, and they didn't really endorse it or anything like that for those lead points. But now, again, because of the new regulations from the Department of Energy, the efficiency ratings that are going to be going up for air conditioners and water heaters, they are going to be, you're going to see drain water heat recovery in those systems and in those building codes as a green alternative. So I just wanted to point that out. Some exciting things coming in 2015.
I believe that's actually the Green Plumbers Code, which is a supplement to the Uniform Plumbing Code, which is really a good thing to be in. It's kind of it's not something that is enforceable, but it's a strong recommendation for people that are trying to conserve energy. And we would love to see it become mandatory, but in order for it to become mandatory, it has to be a life, health, safety issue. But that's fantastic that they're finally recognizing the value of these products, and I've been touting their availability and the need for their application for over 20 years.
Okay, Mark, I'm back here.
Okay.
Okay. Anyhow, as Rick pointed out, there's a lot of really neat things going on, both in the market and with regulations. But so we're just really anxious to see what happens with all this in the future. Okay. Let's see. Here's ratings. Let's see. The drain water heat recovery systems reduce the number of HERES points by 1 to 3 points, and these systems are not new. They've been out in the market for 20 years, and right now, amongst all the manufacturers, there's probably about 35,000 drain water heat recovery systems installed in North America. So, they're out there. They're just not well known. So, this is a typical picture of our drain water heat recovery systems. The top picture there is our new, what we call our Y model. It's a single coil of 3/4-inch tubing, and the other models are variations of that. And the little small one there, that's actually a heat recovery. That's actually used for ice machines. So we actually take the drain water from ice machines, the melt water, use that to pre-chill the water going into ice machines. And that's really something neat, especially in the warmer climate. So it pre-chills the water from, 80, 90 degrees, like in the tropical areas, down to something in the neighborhood of about 40 to 50 degrees.
So that's a cool waste heat recovery then, or a cool recovery.
Yep.
Waste heat.
That's right. And, all of our systems, they work in either direction. Heat to cold, cold to heat. It just depends on what your particular application is. So all they are heat exchangers, and it's fairly simple as far as they go. And here's a couple. Yeah.
Can you go back one?
Yeah.
Am I coming through the mic yet?
You're coming through.
Okay. One of the things that a lot of
Nope, you're not.
Okay.
Yes, you are. No, you're not.
No?
No, you are.
Yes?
Yes.
Okay. I guess you can't move from this position. So one of the applications that has become very popular is the large commercial cooling towers. Because of all of the hot
You walked out again. Nope.
No.
Okay. I'll come back to that. I'm going to change mics out.
Okay. Okay, I think what Rick was going on about was cooling towers for medical use. A lot of hospitals and medical facilities, they use high-temperature sterilization water, which has to be pre-chilled before it actually goes into the drain system. So what we do with those is take it from the 180 or 200 degrees used for sterilization, and actually cool that cool that down and transfer the heat from the hot water, and use that to preheat the water coming back into the hot water heating system. And most places, you're not supposed to be dumping water into the drain system, and it varies, I guess, depending on where you are, but they definitely don't like it going in over 120 degrees, and they prefer it somewhere down around 70 degrees. So what we do is we actually provide cooling towers for these applications. Okay, now these coils here, these are air conditioning heat recovery systems, and what they do is they transfer the superheat from the compressors, which is the compressed, heat energy from the compressed refrigerant. And the one on the left, the pool flux, as we call it, that actually is a pool heater, and it runs right off of the compressor, and it actually takes the place of the entire condenser coil. And it transfers all that heat energy directly into your pool water. And this particular unit will handle up to 55 gallons of water per minute. And the heat rise you'll get in your pool, that's really a variable. It depends on the size of your pool and whether it's indoors or outdoors, so it's kind of hard to tell you exactly how many BTUs are going to be transferred and how fast your pool will heat it up. But typically a standard, say, 20 to 30,000 gallon pool, you'll raise the temperature about 1 degree per hour if you're using air conditioning constantly. So that's a lot of heat energy being transferred over. The other unit in the box, the AirFox air conditioning heat recovery system, that works off of your air conditioning or heat pump, and that's really nice, especially in the warmer climates where you have a lot of cooling ones for air conditioning. But that transfers the heat energy from the superheat directly to your domestic hot water. And we have a lot of customers that actually turn off their hot water systems during their cooling months, because these actually produce about 7 to 10 gallons of hot water per ton of air conditioning. So if you're gone most of the day, it's very easy to recover, 55 or 50 gallons of hot water into your hot water tank. These augment your hot water system, and they can actually turn them off completely depending on how much air conditioning you use. And we
Question for you: what is the heat
have systems that will actually go up to. Yep.
What is the internal
on the left-hand side
material? Yeah.
Okay. Actually, the coil on that is it's a corrugated titanium tube. So it resists the corrosion from all your pool chemicals, and it's compatible with both saline and chlorine-based pool systems.
Excellent.
So, yeah, it's a real nice coil, and should last the lifetime of your plumbing system for your pool. So,
Hey, Kurt?
Yep.
Am I back on?
You are back on.
I'm using a pair of microphone headset, about 50 years old. Works better than the brand new ones you just got us.
Okay.
Take those back. I was going to say, talked this week with David Dobbins, who is a chief engineer with the utility company over in Concord, North Carolina. In the Carolinas, in fact, when I lived in Virginia, from Virginia down all the way to Florida and across the south, you'll see a lot of heat pumps, both electric and gas. But one of the things that they are telling us is and it's actually been written by the director over at ACEEE, his name slips me. But what they are looking for is the superheater is going to increase the efficiency in the sear while dropping the workload of those heat pumps. And in the southern states, obviously a lot more air conditioning is used. But when you think about those superheaters, restaurants, hotels, anywhere that uses a large amount of water, workout gyms, health spas, things like that, those are the type of applications that are going to probably be where the return on investment, including the installation, because these are not an expensive solution, you're looking at a year or less in those applications. But in the residential, for a home that has a family of 4 to 6 living there, the water usage, you almost can turn your breaker off in the summer times in the south and just have the water supply produced by your air conditioning that you're going to be running anyways. So just one of those things that we've been talking about, and they are being considered right now in the Carolinas and Georgia for energy rebates. So.
So again, there's more exciting things going on there, especially with the rebate systems. And these systems here, again, these are just common sense systems that are easy to install and help reduce your utility costs. And for the installers, these are easy upsells for both the contractors. Okay, I just saw something flash up on the screen here. But anyhow, the systems are just common sense systems. Now, going up to the next slide here, and for the drain water heat recovery systems, here are a couple of typical applications and ways to install the systems. Option one, that's a pretty typical system, and really the way you install these really depends on what the customer wants. The first system here, that preheats basically all of your domestic cold water for the house, and it mixes with the hot water coming from your hot water tank, so you're not quite using as much hot water. The other systems are more typical. Option two, where you preheat the cold water coming into the hot water heating system. That's probably the most common. And then for hydronic heating systems and other shared systems, there's a number of ways you can install these, and it really depends on your imagination as far as how you put these in and what the application is. Every time we turn around, we have another plumber or installer that says, hey, can I do this, or does this make sense? And after we look at it, say, yeah, this makes sense the way you want to do it. So if you have any questions concerning these type of things, contact us, and we'll help you run the numbers and see what the efficiencies of the systems are. Okay. Here's a typical application, as we were showing before. The drain water heat recovery systems preheats the incoming cold water, which is pretty common sense. And the neat thing is these are double wall vented devices, and there's no risk of contamination. The gray water or black water going down the drain goes through a 3 or 4 inch DWV copper tubing, and the coil on the outside is wrapped around it. Then there is no risk of contamination between your domestic water coming in and the gray or black water. If there is a leak in the DWV, then basically what will happen is it'll leak out onto the floor, but there should be no way of that happening.
Hey, Kurt?
Yep.
Another application, in these, we just had one of our customers just changed over their complete plumbing system for their bathrooms. They're over in the northeast part of the United States, and you'll see a lot of cast iron out there, the old cast iron. After replacing his whole cast iron main drain with PVC, he said that the temperature increased about 16 degrees when it hit the drain water heat recovery system that he had installed versus the cast iron. So if you are doing a remodel, or you know someone who's doing a remodel or a gutting, even on the commercial jobs, we did a military barracks in Georgia this past year where they gutted everything. They actually took out the old drain water heat recoveries from about 20 years ago. They were in perfect shape, but they were not allowed to reuse them, obviously, for sanitary reasons. They bought new ones, and they increased their efficiency just from going from the cast iron to the PVC. Thanks.
I think that probably has to do with the fact that plastic is such a terrible conductor of heat, which our industry is aware of, but we use it for radiant heating all the time. It's okay when we do it. It's not okay when anybody else does it, but it's okay when we do it.
Yeah, that's an important thing, especially like as Rick just pointed out there, the cast iron going down, through the older buildings. Water to metal heat conduction. That's how we make our money, you might say, as far as our systems are concerned. But when you're talking about the cast iron piping, you're losing all that heat energy out to the atmosphere in the walls, just being dragged out of the water from that water to metal contact. So yeah, if you change over everything to PVC or insulate your existing pipes, your drain water at the drain water heat recovery systems will increase dramatically. And that will, make our systems even much more efficient and recover a lot more energy. Now, Rick was mentioning barracks and hotels and a few other things. Now, here's a typical application for a multi-unit building. We could put these in. There's a number of ways we can install these. This is a pretty typical installation where the drain water is, the recovery units are installed in the walls, and they basically feed throughout the building. The applications are apartments, hotels, barracks, and hospitals. And it also depends, this particular picture shows it in the walls, point up the stacks in the buildings, depending on your application too, and especially if it's a retrofit. If you have a mechanical room in the basement, then they could be used down there. We have a number of applications where we actually develop manifold systems in the facilities downstairs in the basement to recover all the drain water heat from the entire building. And it depends on, like I said, your particular applications. Here's another commercial type of installation. This is a restaurant or food processing, and one of the problems here is the dishwashers and a lot of food processing equipment. They use high temperature water, anywhere from 140 to 180 degrees. And like I was mentioning earlier with the medical applications where they're using the water for sterilization, here's the same situation. The drain water coming from the dishwashers can be 170 degrees. We have to cool that water down before it hits the drain system. So what we do is we actually use that hot water to preheat the water coming into the domestic hot water system, and then raise it up for the dishwasher. But here, like we have a cooling wall, what we call a cooling wall, and there the drain water goes into a sump through a pump, and then down through the cooling wall. And we can take that from 170 degrees down to somewhere in the 90 degrees very easily. And we have one application going on right now where the restaurant had a grease pit, and the water going into the grease pit was way too hot, and all the grease, along with the superheated hot water, was going right out into the drain system. So they were looking at replacing the grease pit, which meant that they had to tear up their parking lot, close the restaurant, and basically a major reconstruction effort. And we proposed a cooling wall similar to this for a fraction of the cost. And the nice thing is not only is it cheaper than pulling up the parking lot and closing the restaurant for a number of days, but they're actually going to have a payback period on this particular system because they're going to be using all that hot water to actually preheat the water coming back into their hot water heating system. And so rather than just pay a lump sum for a small retrofit for the little problem that they had with the grease, this system here actually will pay for itself within about a year. Wow. So,
hey, Mark.
Yes.
Also, if you have any customers or clients that work with commercial laundries, we are doing a commercial laundry in New York City, and this is almost going to become a standard there because they are complaining about the hot water, the temperature of the water going down their sewer system. we're going to try to reduce the rat problem in New York by cooling down the water. For commercial laundries, we have 2 that are working right now. Kurt did the initial engineering on those. We were looking at anywhere from 8 months to 1.2 year payback. That was with an 8-pipe manifold system. So commercial laundries, restaurants, again, these are high volume usage as far as hot water, high volume disposal of hot water, that we're able to help them in 2 ways. Help the municipality with the lower temperatures going into the sewage systems, and reclaiming that heat to preheat the new water in those applications.
Fantastic.
Yeah.
There's the laundry.
Yeah, here's the laundry.
Wow.
As you can see,
Wow.
yes. Yeah, there's a manifold system of a typical laundry application. And as Rick was saying, the problems that of the hot water going into the municipal drain systems, we've got to cool that water down. But on top of that, that's a lot of hot water and a lot of heat energy that we are able to recycle. So in New York City, the typical groundwater temperature is about 50 degrees. It's about 45 in the wintertime, about 55 during the summertime. Remember, they get a lot of, New York City gets a lot of their water from up in the mountains, and it's pretty cool up there.
I've actually been to the headwater sources for the city of New York, and there are environmental police driving around in cop cars that have the authority to stop you if you're speeding because you are damaging the environment. They are serious about their water source.
Well, when you have that many people piled up on top of each other and yet that's their water source, they get a little bit antsy about it, so I can understand that.
If you're in New York, don't talk on your cell phone either. You're getting a ticket.
Oh, but yeah, anyway, as you can see here, here's a typical, laundry system, and large commercial laundries, coin-op laundries, either one of those, they use a lot of water. I just did another estimate for another laundry that was using 72,000 gallons a day of water at 150 degrees. So that's a huge heating cost, especially when you're talking about heating it up from about 50 degrees up to 150 degrees. There was an annual gas bill just for heating water alone was about $300,000. And the estimate we had for putting in our system, along with a lot of other devices that they were looking to install, we would recover almost a third of that cost within the first year. So you're looking at $300,000 bill for gas heating. We could recover about $100,000 of that, and our portion of that project, just for the drain water heat recovery system, was probably about $15,000.
Wow.
So it's a much larger project because they're installing new high-efficiency washers, continuous flow washers, and things like that. A lot of other high-efficiency parts to the system. But just our portion alone almost paid for the complete install. And as you can see, $15,000 investment, you save $100,000. It makes sense. And these things, there's no operational maintenance to do on these. Once you install them, you forget about them. The only thing you have to do, just like with the rest of your drain system, is if you're subject to clogging or something else like that, these do not add to any of that. They're just part of the drain system. All we do is it's a straight pipe on the inside, typical DWV. There's nothing, no fins or anything else on the inside for sediment or anything else like that to build up. So once you install these, you forget about them. You don't have to do anything. They're self-cleaning, but they recover a heck of a lot of energy. And if you're using electric for heating or propane or fuel oil, the payback period decreases dramatically. The cost of energy for those is a lot higher.
Yeah.
But testing and certification. All of our systems are ETL, WH certified. Every time we come up with a new model, and all of our existing models have been certified, and we have the certification numbers for them. They all meet the APSM 88, NSF 61 copper for the exterior coil. That's, for all potable water use. B306 for the DWV. And, of course, there's the UL and CSA standards there. And one of the things that you really have to look at, especially with potable water systems, is these are double-wall vented construction. And as I mentioned earlier, it's done like that, so if there's ever a leak with the, black or gray water, there's no chance at all for cross-contamination into the potable water systems.
Hey, Kurt, back on that testing, I noticed that the CSA standard is almost the international standard. It's B55.1 and .2, which our products fall under and are approved for. There are other heat exchangers around the world. China and Australia both have them, but because they're not double-walled and they have a high percentage of lead in their copper, they are not approved for drinking water. So it has to have that NSF 61. Also because we do not solder or braze the outside coil directly onto the DWV, that is part of our unique design. What happens is the ETL, when they inspect our facility, they inspect to make sure we don't have certain contaminants, oils, that we're not doing brazing to brazing as far as the outside tube to the inside tube. So these are real rigid inspections, but you can feel secure that in any application worldwide, our product would be accepted for the Canadian standards.
Okay. Here are a couple of typical installations that we have, showing different ways to install. Can you hear me? Okay.
I'm sorry, Kurt, I had to mute you while he was talking. We keep getting echo back.
Okay. All right. So anyhow, here's a couple of installations that we have. As you can see, there's different ways to install it that are different manifolded or single coil systems. The one on the lower left there, that's in a parking garage, but that's for an apartment building, and you can see that there's a lot of copper sitting there. That handles a lot of drain water, and a couple of residential installs here. And the one on the lower right, you see a white pipe there. That's actually in a barracks down in Fort Carson. When we delivered the units, they actually spray painted them white so they wouldn't be as susceptible to theft.
That's a very good idea.
Yeah, they, when you see all that copper there, especially out in the open, you got to consider a couple things. But anyhow, that was a typical install for the barracks down there at Fort Carson. And so anyhow, we just wanted to show a couple different ways to install these things.
And by the way, for those plumbers that are viewing this, you will notice that as an example in the upper left-hand corner, they're showing the use of a conventional drain waste and vent type of fitting, close radius elbows and T's. And the only reason that that's possible and feasible is because of the fact that this fluid is being pumped on the drain side of the system. And actually, Kurt and I have had a couple of conversations about trying to parallel numerous units together with gravity feed, and it's virtually impossible to use a combination Y and 8 bin backwards. So really the only way that you can do these where you've got a batch of them that are batched together is to have a sump, have a pump, and then enforcing that water through these sanitary T's, it's a non-issue. This is an area that the code officials are going to have to become aware of because they're used to seeing things done with combination Y and 8 bin directional flow fittings. But with the fact that you're using a pump, those rules all go away, and it'll take them a while to get used to it and realize, oh, yeah, okay, that works just fine. They haven't seen the huge drain waste heat recovery systems that I've seen that have like a 20-ton refrigerant compressor on them and a sewage grinding pump, and they would die if they saw those. They go, whoa, wait, you can't do that. You can't run sewage through a flat plate heat exchanger. Well, yes, you can. If you got a big enough pump, you can pump it up any hill you want.
Now, we are using, only because what you were saying, Mark, those fittings, a lot of times those fittings are 4 times more than our actual unit. They're very expensive. So what we have done is actually, in any application that we can with the pumps, go with a high pressure, high temperature on the top side for your headers. The schedule, is it the Schedule 80?
Yeah.
Yeah. And we've had no problems with the plastic expansion or anything like that. Now, on the footers, you can use regular Schedule 40 because you've cooled the water down. But when you work with those brass fittings, they are very expensive. Just be ready for that.
No, been there, done that, and paid for them.
Oh, yes. Yeah, another thing, too, is especially with the PVC, all these headers that you see in these pictures, they actually can be manufactured by the installer on site. We can design them for you, and we can manufacture them, but that's an extra cost to our coils to begin with. But these are, especially with the PVC, these are very easy to make on site and customized to your specific applications.
Very clean. You mentioned that you were painting them white down there in Fort Carson. My good friend Dan Holohan at one point in time was called into a job in New York City, and he said that it was a pretty tall building, and he said the guys were up on the top of this building getting ready to make their final connections to this copper heating main, and all of a sudden the pipes started going down in like 1-foot segments. And they're like, what the heck? And they hightailed it all the way down into the basement, and here was a couple of guys with the Sawzall that were taking the copper out that had just been installed that day. And his simple solution was paint it black. If you paint it black, they won't touch it, and they did. From that point forward, they would paint all their copper black as soon as they got it installed, and nobody would mess with it. They'd look at it and go, oh, that's steel. It's not worth anything. Don't mess with it.
Right. We actually have changed even our shipping process, whereas it used to be in the insulated cardboard and wrapped and things like that. And we had an instance in South Carolina a few years ago. They delivered them on the truck on the pallet, and you had all these cardboard boxes. They got wet, and then somebody hit a corner of it with the forklift, and they saw shiny copper. And that whole shipment was stolen overnight.
Yeah.
So we now use recycled wood, and we build boxes. We wrap them in the bubble wrap inside. They are screwed down. Are they absolutely secure? No, nothing is. But it's a little bit harder to get to or to see what's going on inside there than with the cardboard.
Live and learn.
Mm-hmm.
I know another question that will probably come up is the fact that none of these lines are insulated, and I know that Kurt and I have had this conversation before, but you might explain to the audience why it is that you do not insulate the exterior portion of the heat exchanger.
Well, that's pretty interesting. In fact, we have an application that we just did this week, which is actually really outlines this reason. The cold water coming into these coils, the groundwater temperature, especially in the north, like here in the Colorado Springs where we are, during the wintertime, the water comes in at 43 degrees. Whatever room that these things are sitting in is usually a lot warmer than that groundwater temperature. So what they do is they actually absorb the heat energy from the atmosphere and help to temper the water in the coil. Even if there's no water running down the drains or throughout the piping systems, these will actually preheat the supply water to whatever the ambient temperature of the room is. And the only reason you would want to insulate these at all is if that room has a chance of going down below 32 degrees. Now, we just did an installation this week, which we are actually running tests on with monitoring systems. It's in a residential boiler room it's actually in Tina's house. We installed it in Tina's house, and she has radiant heating throughout the house, and the boiler, the room is probably about 10 by 10, and that room is constantly somewhere around 80 to 90 degrees, depending whether the boiler's running or not. And once we put the system in, we noticed that the groundwater temperature was coming from right now it's about 50 degrees. It was being heated up to the room temperature. So the water in all the coils and the plumbing in that room is now being raised up to about 80 to 90 degrees. And that's before any drain water is actually, being used. So once the showers start running and things like that, you have probably, 4 or 5 gallons of water just in one coil that has been tempered to whatever the room temperature is. So we're dumping that slug of preheated ambient tempered water right into the hot water system just before all the hot water coming down the drain actually hits the drain water heat recovery unit. So does that answer your question?
It does, and I'm sure that there's probably not a person that's viewing this that has never seen a cold boiler room. The boiler room I've ever been in is like 120 degrees.
Right. Well, one of the things that one of our new products is a drain water heat recovery monitor, which actually monitors what you're recovering as far as BTUs, the transfer heat from drain water over to the supply water. Mm-hmm. And once we installed that into the system, this new system in this boiler room, initially we got some very unique readings that I wasn't quite expecting, and then it was like a aha moment. It's like, yeah, this is really absorbing the heat out of the atmosphere of the room. And, just in that alone, all the copper tubing in that room was preheating all the water for the house. So real neat example of why we don't insulate these systems. Anyhow, moving on to the installation of these systems, we've repeatedly said that these are very easy to install. You use standard plumbing tools. There's nothing unique about these things as far as no special tools required or anything else like that. There's in new construction, these can be installed just right alongside all the other drain water systems and the existing plumbing. And for the plumber, it'll take probably an extra 10 minutes, especially on a new install. Retrofits, well, we know how retrofits are. Usually they're pretty easy, but sometimes you have, that one application that, you wish you weren't there for. But generally speaking, especially if the drain stack is open, these can be put in very easily, usually less than an hour. If you're talking to the plumber, maybe a little bit more, but generally speaking, you're looking at less than an hour of labor to put these things in. The actual installation of the actual drain water heat recovery unit to the drain stack is probably the easiest part. Then probably the most difficult part is actually routing the water to and from the coil. And that just really depends on what your specific application is. Now, I'm going to go through the next couple slides fairly quickly, but just going over a typical installation. Here, you can see the drain stack coming down, typical application, and you just find out where you want to install this, clear your workspace out, turn off all the water, flush your toilets. Of course, you don't want any surprises coming down there from somebody that doesn't know you're working down there. Installing the unit. Basically, what's that?
Why do you want people not to flush the toilet when you've got the pipe disconnected?
Well, it's Christmas, but we don't want any extra presents coming down.
I can't tell you how many presents I've had to land on my shoulder in the 38 years that I've been working on drain waste event systems. It's like, oh my God.
Yeah. So, especially if you're in a house where you can control it a little bit, you go up, you flush all the toilets prior to anything, and, make sure everything is drained, just to keep that person up there that is unaware just from, flushing toilets. But anyhow, the installation of the unit, you basically measure it. If you have a 48-inch unit, you measure out 48 and add a little bit for the couplers that you're using. Here, I said, add an extra 1/4 inch. We've had a couple of plumbers say maybe an extra half inch to the measurement. You know, a lot of that depends on how cold it is, how easy the rubber is to move, and also the particular coupling you're using.
Yeah, how much free play you've got on the pipes to be able to move them up and down.
Right. So if you have no free play, then you might want to add a little bit more to it. But any plumber that's you know, used these couplers before, they realize that these are fairly easy to use. You just roll them back and install them, and you know, real easy to put in there. And you know, you just mark it, cut it, and put it in. Very easy. This is probably the easiest part of the installation. Let's see. Basically, one thing you want to do is make sure that the cut that you make is square, and you also want to make sure that you remove any of the burrs on that DWV, you know, from cutting. You don't want anything, you know, getting in there causing leaks with your couplers. So you just cut it, remove it, install your couplers on there, roll them back, drop your unit into there, and go ahead and cinch up your clamps. And that's about all there is to it. It's very, like I said, it's very easy to install. You don't need to be scared about that as far as, you know, getting into these things. Rick actually went out to Utah to show a plumber how to use it, and the whole installation took 10 minutes. That was in it was a new construction, but they had never used one of these units before, so they wanted somebody to basically hold their hands while they installed it. And one of the comments that the plumber made was, this thing almost installs itself. But, you know, just real easy to install, especially with an open installation like this. One thing, our units come either with the fittings either straight up or on the out, and you can order them either way. But they accept standard fittings. So if you're going copper to copper, copper to PEX, or whatever you're using, you just drop in whatever type of fitting you need in there. Sweat it in, clamp it in, whatever you need to do. So it's just standard fittings. And then the hardest part is actually run the water line to and from it, just the routing. And with PEX anymore, that's a fairly easy job. So you just, nothing special there either, just standard PEX to and from it. One thing to note is when you route the lines, these are counterflow heat exchangers. So the supply water actually enters in through the bottom of the unit and then counterflows against the drain water up towards the top. It makes it a little bit more efficient that way. And then the supply water leaving the unit back to the hot water system or back to your back to wherever you're using it is actually out from the top. And that's pretty much it. That's a completed installation. Real easy, and just cinch things up. That's all there is.
Good question for you. I know commercially you're going to have a pump situation where you're circulating water between the heat source and the heat load. Residentially, do you ever set up a scenario where you've got large storage tanks and controllers and pumps that will circulate water?
It depends on your application. If you're using a lot of constant flow water, like with showers and things like that, you really don't need the pumping system. But if you're using, say your family uses takes tubs rather than showers, you have a big surge of hot water usage, you use it, and then you wash it down the drain. And when you wash it down the drain, you know, you don't have any circulating supply water. So what you may want to do there is put a circulation pump that when the drain water is going down there, the circulation pump turns on and circulates water to and from, say, a tempering tank. So you actually use that warm water from the bath to preheat your water going into your hot water supply through a holding tank. That's one application you can do it. And if you are, if your application is something where you have, you know, large amounts of water that is used periodically, where you use it and then you get rid of it, separate from like the tub situation, then you might you know, benefit from using a holding tank and a circulation pump. That make sense?
It does.
And to add to that, a couple of our plumbers, especially over in Utah, what they're doing is they're doing the recirculation. Anytime you're using recirculation or the instant hot water, these are really a great add-on. For any of the plumbers that are out there, or if you're talking with plumbers, any plumber who is trying to help their customer with their bills, their utility bills, and want to add a green option during a hot water tank changeover. If you're changing a hot water tank, it's a perfect time. If the access is there, our plumber that just did the one, I think the install bill for everything, the PEX and everything was like $132. So it's not a big expense to add on. And then in the new home, the one thing the plumbers will want to be, or the contractors will want to be careful, is make sure that we have the building secure. The windows are in and the doors are in. Again, so we don't have anything walking off in the middle of the night when they see a shiny copper pipe. But the recirculation, the plumbers out there have been very favorable, and it depends where you're at in the country. Some of them are like, oh, that'll never work, I don't want to do it, and then you have some that are like, yeah, this will enhance the system that I'm putting in.
Mm-hmm. And one other thing I'd like to point out, Rick mentioned tankless water heaters. These systems are compatible with any type of hot water heating system, whether it's geothermal, solar, tankless, tank. All we are doing is we are recovering heat energy from the drain water and using that to preheat the water coming back into whatever type of hot water heating system you're using. So, they're compatible with everything. Another thing too, well, you mentioned recirculation. We'll go and I'll mention this when we get to the air conditioning heat recovery. Your applications, depending on how you use them and how you hook them up, you really have to look at what you're doing to get the best benefit from these. So you can hook it up one way and get a benefit, or you can hook it up another way and maybe get a little bit more out of whatever system you're using. And of course, there's a cost-benefit analysis you need to do too, is how much it's going to cost me to get a little bit extra out of it. But anyhow, as far as the drain water heat recovery system is concerned, that's how easy it is to install. You just check for leaks and you're done. And as Rick mentioned, if you're changing out a hot water tank, prime time to add one of these to it. Tankless hot water systems, one of the things we hear a lot is whatever the tankless hot water system is rated for, it tends to be a little bit less than advertised. So these systems actually augment the tankless hot water system, so it actually preheats the water coming in to help them out. So if you have a tankless hot water system that's rated at, say, 5 gallons per minute, in the wintertime, you're probably not going to get that full 5 gallons per minute, especially at the temperature you desire. But with a drain water heat recovery system in there, heating the water coming into the heating system, it'll help it out. So it'll actually make it work a little bit more efficiently. So anyhow, in the air conditioning heat recovery, this is a neat system for us, and this is where we actually use the waste heat from air conditioning compressors and use that to heat your hot water. The air epoxy superheater recovers up to 25% of the superheat from the compressors before the condenser coil. We don't want to go more than that, because that if you take too much of the superheat out of the refrigerant, it actually starts working against the air conditioning system. So you don't quite want to do that, take all of it out there. It reduces the back pressure on the compressor, which also reduces the electrical load on the compressor. So not only are you recovering heat energy from the refrigerant, you are actually reducing the load on the compressor. So you're saving electricity on top of that. And a typical number for that, on average, is you probably see a 7% reduction in your electrical load for your compressor. Pool Fox heaters take the place of the entire condenser coil. And you can actually use a valve system in there, so you can switch it in between the pool box or the condenser coil as needed. So if you have an application, like say in the South, where you're using it to heat up your pool during the pre-season and the postseason, during the summertime, you may not want that pool heated, so you might want to switch back into your condenser coil. So the air conditioning installer can actually put a valve system in there, little electronic valves to switch between the pool box and the condenser coil. And both systems are fully compatible with the regular air conditioning systems and heat pumps and a number of the common refrigerants that are out on the market today. Okay, here's a pretty typical install where you have the air conditioner, heat pump, and then you have the square box up there is the superheater, the what we call our air box, and then the cold and the hot water recirculating back and forth between the hot water tank. And again, just to mention, there's a number of ways to install these into the hot water tank, and it just really depends on your application is. Here's, basically a very basic install where you can see the refrigerant runs up to the air conditioning heat recovery unit, and then the water to and from the hot water tank. Now, what I don't show on here are the check valves and valves that are required for your particular application. And also, like I said, there's a number of ways to install these. I have one plumber that's actually using the circulation pump in the pool box to circulate hot water throughout the residence, so you have on-demand hot water throughout the residence. So what it does is it pulls the water from the hot water tank on the supply side, heats the hot water, and then circulates it throughout the house, and then back into the hot water tank. So wherever you are. Yeah.
Real quick on the installation too, just on the physical aspects. The ideal situation in the South is to place this box or place our superheater outside just above the condenser or your air conditioning unit outside. If you don't have that application, or if you're in a northern state and you want this, and say it goes into a basement below that condenser, you turn it sideways so that you don't have any kind of oil clogging or anything like that. Makes it easier for the flow. Still going to work just as well. It's just one of those things that you want to, and we do have some commercial applications where the AC units are up on the roof. The same thing. In the colder climates, they're going to want to put those inside, just underneath, over the top of your hot water tank. Turn them sideways, and you have no problem with any kind of oil or anything like that catching up inside of that tubing. All right?
Hang on just a second. I have, there you go, back on.
Okay. As Rick mentioned, in colder climates, if you're in an area where you get deep freezes, you probably want to put these on the inside, for the cooling season, or during your heating seasons. If you're in a moderate climate where you only get temperatures drop it down below freezing occasionally, these systems also have an option in there, what we call a freeze stat. So if they sense that the water in the coils is actually getting down to freezing, it'll actually turn the circulation pump on and circulating just a little bit of water through there just to keep it from freezing so you don't burst your pipes. But if you're in a hard freeze climate, you would actually be running your water there quite a bit. So you would actually be sucking water out of your heating system to keep the pipes from freezing. So you don't want to have that happen. So you definitely want to put these on the inside or drain the system completely during the cold seasons. But if you put these on the inside, you should have no problems with that. Now, this diagram here shows a couple of different variations of how to install it. The unit on the right, HK5, that's actually a single tap unit where it plugs into either the top output of the hot water heater or into the drain plug and go into either place. And what it does is it circulates the water. There's a plastic tube in it that sucks the cold water from the bottom and then counterflows the water back in, the hot heated water back in. So it's kind of a dual flow tap, you might say. But that's just an option that comes with these things. It just really depends on what your application is.
You stole my idea. Been doing that for a long time. It's okay.
Oh, well, here's a typical application. These are commercial units for a restaurant, and kind of a neat story with this restaurant here. This is actually down in Jamaica. Now you can see the square unit on the upper. Let's see, on the left picture. This is a dual compressor system. So anybody that has any questions about whether you can use this on multi-stage systems, the answer is yes. We have multi-stage systems available up to four-stage system. This is a dual-stage system, and the superheater is the box on the top left of the air conditioning unit. And the compressors, you can see there, 2 compressors, dual-stage system. Now, this particular application, they were using about 150 gallons of water a day. This is a
Kentucky Fried Chicken?
Kentucky Fried Chicken, yeah. It was a Kentucky Fried Chicken down in Jamaica. Fast food. They served about 500 meals a day. But after the installation, they turned their hot water tanks off. They were using electric heat, electricity for heating. And down there, the cost for electricity is about 43 to 45 cents a kilowatt hour, so very expensive. This particular system basically saved them, it paid for itself in about 8 months with the, because they turned off their hot water heating system. They were able to reduce their energy costs. They actually increased their hot water usage because they were able to use the hot water now for cleaning more often. Before they had to do their cleaning in stages. Now they're able to do it as they needed, and they're using 140-degree water, commercial systems. So they...
Kurt, how many ton was that? Do you remember off the top of your head? Is that about 10 ton?
That was a 10-ton system.
Okay, and that was the dual system? Dual circuit?
Yes, that's a dual circuit.
For those who would be interested, just to give you an idea, for a 6 to 10 ton system, dual circuit, those units only retail at $1,700, $1,775. So you're not talking about a large expense. And when you figure out what Kurt was saying about the electricity versus the cost, there was an installation charge obviously in there, but still, to be able to pay for itself in 8 months is pretty remarkable.
Again, these are systems that just make sense. You can sell these to your customers very easily, especially when you show them what the return on investment is. When you take your fuel costs, whatever you're using, gas is the cheapest. So, when you see a return on investment that's, especially with commercial units, that is under a year, that's a big benefit for any type of commercial entity. And if you're using propane, fuel oil, electricity, or any other thing, the payback period is significantly reduced because the cost of fuels for those is dramatically higher. I have toying around with an installation right now that uses fuel oil for for heating both the buildings and the domestic hot water systems, and they are desperately looking for any type of alternative way of heating water right now. Their fuel costs are tens of thousands of dollars a month, and you put systems like this in, the recovery on that is dramatic. It pays for itself very quickly, and these systems are, like I said, all these systems are fairly easy to install. The air conditioning systems are a little bit more complex because you have to break the refrigerant lines and install our system and then recharge them. So there's a little added labor for that. But there are ways to do that without fully draining the system. But other than that, once you look at the payback period, it makes sense to put these systems in. Now, again, here's a pool fox. same type of system. I just have a picture with the same compressors here, but again, when you put these in line with the refrigerant system, or in line with the refrigerant flow there, and use this to heat your domestic hot water or pool water or whatever you're using, there's a number of benefits. The air conditioning systems work much more efficiently because there's less pressure. There's water to metal and gas. Heat transfer is much more efficient than the refrigerant to the metal to the air. So it increases your efficiency for your system dramatically. Okay, and again, installation on these things, there's nothing really special required. Any typical type of HVAC contractor should have everything on their trucks to install these. There's nothing really outstanding as far as whatever, special tools required. So with both systems, basic plumbing tools, basic air conditioning tools, very easy. Probably the hardest part is actually, especially with retrofits, is probably running the water lines to and from your hot water systems. Benefits, reduces the load on the compressor, reduces the power consumption by about 9%, 7 to 9%. So you added, you have an added benefit there of reducing what your electrical costs are on top of your heating costs. Makes use of the waste superheat energy. So it's waste heat you're just blowing out into the atmosphere. Now you're reusing it. Commercial applications, especially restaurants, and you see a lot of those quick marts and everything. Even in the wintertime, they're running air conditioning all year round. So you can make use of that. Like in the kitchens, they're running their air conditioners even in the middle of wintertime, trying to keep the heat down in the kitchens. And of course, they have walk-in refrigeration units and freezers. So you can make use of all that, the chillers. And as you can see here, you can generate 7 to 10 gallons of hot water per hour per ton. So, and the larger units, we can get up to 20 gallons per hour. But see, what else do we? Oh yeah, we have a lot of clients that turn off their hot water heating systems, and I've actually heard stories from a couple of our installers where their customers actually use hot water to water the grass. And the reason they do that is because the air conditioning heat recovery systems make the air conditioning run more efficiently, so they're not really wasting hot water. But once the hot water gets to whatever set point it is, if you're in a residential situation, once the hot water reaches 120 degrees, the circulation pump and the air conditioning recovery systems will turn off, and it will only turn on if it gets up to about 180 degrees, and basically that's to keep the refrigerant from getting too warm. But as long as the water is running through the air conditioning heat recovery system, the air conditioners are running more efficiently. So they actually use hot water more just so they have the water going through the recovery system so the air conditioners work. Kind of an odd thing. Another added thing to say here is whatever SEER's rating your air conditioning system is rated at, like our domestic heat recovery system will increase your SEER rating by about 1.4. So if you have a 13, that'll raise it up to a 14.4. Just another added benefit, shows how it reduces the load on the system, but also increases the efficiency of the system. And all these systems have been UL tested. And here are the number of the reports for testing and certification. And basically what the test reports show is basically how well they transfer heat energy from the refrigerant to the water, and also how the loads on the electrical system are reduced. And also, because they're electrical systems, they have to be UL certified, and they're all enclosed in containers that are weather tight. Let's see. Now, here's an important thing, for the installers and builders, they want to know what's in it for them. And this is where it makes sense for everybody. For the installer, all these systems are easy to install. It doesn't require any special training. You can install them when you're doing something else, like you're changing out a hot water tank or something like that. But it's an extra added upsell. For the drain water systems, you're usually looking at less than an hour. Air conditioning systems, maybe about 3 hours. No special tools required, so you don't need to invest in anything else. For your trucks, easy upsell to increase your cash flow. For the end customer or builder, increases the lead points. We have a number of builders that are advertising themselves as being green, and this is easy green sell to the customers. They're putting in all these high efficiency windows, maybe some solar systems or high efficiency appliances. You put either one of these systems in there, it recaptures all that heat energy that you're wasting. So it's another item in there that's fairly inexpensive to put in, especially for the builders. And it's an extra added benefit to the builder's customers. So when you see these things, walking through a new house, you're looking to buy it and they're advertising green, and you see that nice shiny coil down at the bottom, or the air conditioning system, attached to your cooling system, it just shows that, you are truly a green builder. And for the consumer, this is a big thing. Use less energy, save more money. It's simple as that. Another added benefit, especially with larger families, if you're, in a family of 7 and you're the 7th person taking a shower, you're probably not going to have hot water. So one of the added benefits to the drain water systems is it makes the apparent system look larger than it is. So if you have a 50-gallon water tank, it may help it look like an 80 or 100-gallon water tank, just simply because it's preheating all that water. So the hot water actually lasts longer. And when you're actually looking at mixing hot water and cold water to shower, here in Colorado, again, groundwater temperature is 43 degrees. So in the wintertime, you're actually using a lot more hot water to heat up that water to your desired temperature. But if the cold water is being preheated up to 80, 90 degrees, you're using a lot less cold water or a lot less hot water to mix. So you're not using nearly as much hot water. So you don't run out of hot water nearly as quickly. Consumer benefits, again, actually many of these units can be installed by, especially with the drain water systems, they can be easily installed by a do-it-yourselfer if you know how to do the plumbing. And they're very inexpensive to install if you have a professional plumber do it for you. But they're easy to install. It saves water heating costs, which are a significant portion of your utility bill. Your hot water heating equipment, it saves wear and tear on that. So during the wintertime, especially with gas water heaters, one of the biggest problems with those is condensation. So you have all that cold water going to the bottom of the tank in the wintertime, especially in the wintertime, causes condensation and rust. And you have rust out in the water heaters don't last as long. With electrical systems, you have all the elements. So if your hot water heating elements are turning on all the time for a long period of time, they're going to basically have deposit on those build up a lot faster. With our units on there, that won't happen nearly as quickly. You have a longer shower run time. As I was mentioning earlier, it makes the apparent system look a lot larger than it is. Increase the lead points, and depending where you are in the United States and your utility company, there's the possibility of energy rebates. Here in Colorado, and those of us that use Black Hills Energy, this year, 2014, there was actually a $300 rebate for installing these systems. So if you contact your utility company and ask, you may find out that you may get a good portion of these units paid for. And we're actually working with a lot of other utility companies right now to get more interest in rebates or number of things, as Rick had mentioned earlier. So, when you're looking at this, is a win-win situation, both for the installer and the customer. This is something that makes sense. As far as the customer is concerned, you put these in, it saves money and continues to pay back over a period of time. For the installer, this is an added product, to put in your tool chest of products to help increase your cash flow. Lead points to builders, and of course for the people that want to be more environmentally friendly, this significantly reduces your carbon footprint. So that's,
hey, Kurt,
yeah.
Pretty much to summarize that, if you're a professional out there, if you're a professional engineer, there are obviously, we see this all the time, the LEED Silver, the LEED Platinum, the qualifications for your building. So these are things that are going to benefit them as a designer, and we will be seeing in the next year probably a 40% increase in calls for these as the engineers get used to them, more educated on them, and see the actual testing. We are currently, as Kurt said earlier, we have a live monitor system that we will have accessible to, I don't want to say the public, but for lack of a better word, the public. And we'll have different applications such as residential. We are working on a gym. We are working on a restaurant. And these are in different areas of the country that will actually show the BTU savings and cost savings on a live data basis. So for that professional, as I was saying, the engineer having that design, it's going to help them get those LEED points and that silver or platinum status quicker than a, say, solar system, which costs 4 to 6 times more, if not more than that. For the plumber, the nice thing about plumbers, they normally have a clientele list that client or customer is going to only call them when there's anything that's needed. And plumbers are a lot of times like a doctor. The doctor tells you, well, you need to do this. You're normally going to do it. Plumber's the same way, and this is a great opportunity for the plumber to help the customer save the money and give them a system that's going to last a little bit longer. So those are the overview or the summary of it is that it's a advantage to the customer, whether they want to save money or just want to go green. It's a win-win for them. But for the professional, it's going to give them that leg up in the industry.
Excellent point. I should mention, I have one of these units that Tina's father had given to me numerous years ago for testing and evaluation, and started out with it first. My wife likes to take a bath every night. I cannot convince her not to. So I set a sump, and I drained the bathtub water into the sump, and I had a sump pump that would then pump the water through the heat exchanger on the drain side, and also a preheat storage tank with another pump and a controller that would pump water through on the potable side. And I determined even after parasitic cost of operation that the thing was recovering 50% of the drain heat that was available. From there, I moved it to the exhaust of my modulating condensing boiler, and on the incoming cold water potable side, the cold water was coming in at 40 degrees during the winter months, and the exhaust was leaving the boiler. So during a domestic hot water call, I had a super condensing hot water boiler, and I left it in that position for like 4 years, and got to thinking about it, and I thought, that's silly. I shouldn't have that acidic condensate waste going through that heat exchanger, and went ahead and pulled it out and did an inspection on it, and there was virtually no signs of any etching going on inside of the heat exchanger at all. So it amazed me. Still don't know why it wasn't etching, but from there I moved it to my mountain home, and it is now up there, and I'm sure it's recovering probably 70% of my drain waste heat recovery because she doesn't bathe up there. She only showers up there. All of our uses, they're concurrent for whatever reason, and that works out great. So I've got it set up as the incoming cold water from my well comes in at about 40 degrees, goes to the GFS heat exchanger, and then from there it goes into my solar domestic hot water preheat, and from there into my gas-fired auxiliary, and then eventually to the load. And this is not a normal situation, but these things are fantastic, and I do not understand why they are not mandatory under the current energy provisions of the code. I think it's just a simple matter of time before everybody realizes, wow, we should be doing this as a standard. This should not be an option. This should be a minimum requirement. So,
Well, Mark, one of the things that I was talking about Gary Klein earlier, he's asked us to attend and speak at the ResNet Forum in San Diego in February, and then also join the Hot Water Forum that's going to be in Nashville 2 weeks after that. So we're going to be on the road again. This last year, I think that we logged over 40,000 miles driving, just going city to city, doing the demonstrations, talking with builders, contractors, designers, and we're seeing a better interest. And for the life of me, when I saw them, I knew exactly what it was and how it worked for the first time. It was maybe 4 or 5 years ago when I first met Kurt and Tina. And I'm talking with plumbers that have been around for 30, 40 years, and they're like, well, I've never seen anything like that. That's a great idea. So it's amazing that in Canada, in the Ontario building codes, they are a standard. We are trying to get those here in the United States, not just as an industry, but because the technology works. It's simple, it's efficient, it's economical, it works. And that's really where everything is going to be going, I think, in the next 2 to 5 years.
and in most cases, it has one moving part, water.
Exactly. And the other thing is people are not going to give up their creature comforts. They're not going to give up their nice long showers. They're not going to give up their air conditioning. So while you're doing something that you're going to do anyways, you might as well reap the benefits of it and capture that wasted heat, otherwise just going down the drain.
Good point.
So, but anyhow, we're talking about all these, why it's not a specific code or mandatory. And, you look back and, for a lot of people, like Rick had mentioned, they'd never seen this type of thing before. And it's one of those things, people are a little skeptical about how well it actually works. Now, we just put the drain water system into Tina's house, and we were testing it. Now, we were running just hot water down it to initially test both the unit and the meter that we installed. And what we were seeing with that, with probably 2 sinks running, call it about 5 gallons per minute at 120-degree water, we were recovering almost 70,000 BTUs per hour off a 48-inch coil. That's a kind of a unique situation just because it was hot water, but with the showers and everything running, typically with our coils on, you'll see somewhere a recovery rate of between 25 and 40,000 BTUs per hour. And you add that up, that's a lot of heat recovered from your drain water systems. And you convert that into the actual cost for heating, and you can actually see what the payback is. Now, the meters that we're putting in right now for testing, they will actually help show what the recovery rates of these systems are. The more hot water you use, the larger the family you have, your application, if you use a lot of hot water, whether it's a commercial system or not, the more hot water you use, the quicker the payback. Now, obviously, if you're a family of 1 or 2, the payback is going to be much longer. The only benefit you actually get is reducing your carbon footprint, really. But if you're a family of 5, 7, 8, you're a school. But lots of people in your family, then you're going to see a real quick payback on these things. So it just, again, makes sense. And we're going to go over what the payback is here. Now, here's an example. If we had a community of 100,000 households, and most of the numbers that we'll see last year are based on national averages. So the national average is 3.1 persons per household. I'd hate to be that 1.14 person. But you're looking at that. If we put a drain water heat recovery system in just 25% of the households, here's an estimated look at what we would save in BTUs per year. And when you look at the number of kilowatt hours and the number of therms that we save here. And yet that's community-wide of 100,000 people. Now this has a, significant impact when you're looking at the infrastructure systems of our utility systems. So we have more people moving into places. The utility systems are outdated. So this actually, for the utility companies, this actually prolongs how long it's going to be before they actually have to do updates to their systems. Now they're constantly doing, updates, but when you're looking at the grid systems and the distribution systems for gas, it takes a long time to meet the upgrade the systems to meet the increasing demands. So this is one reason why you would want to use these systems, especially with the utility companies. Paybacks. There's a lot of factors involved. We have to look at each application to determine exactly what the payback is, for a specific system. How much water are you using, the cost of the energy that you're using, the incoming water temperatures, the wastewater temperatures, the distance between your drain water heat recovery system and the hot water unit. If you have a drain water heat recovery system on one end of the house and your heating system's at the other end of the house, you have to run water to and from both systems. So by the time you take a shower, you may not get the added benefit. So the ideal situation is when the drain water heat recovery system and the drain stack are right beside or very close to the hot water heating systems. See how much hot water you're using in the system. These are all factors determining what the efficiency of the overall system is going to be, along with what the payback factor is going to be. For households, using national averages again, return on investment is 2 to 7 years, and that depends on the type of energy you're using and the number of people in the household. The benefit that you'll see immediately is your energy costs will reduce right away. As soon as you install the system, it starts paying for itself. Instantly increases your water heating capacity, increases the resale value of your property. One thing that you would want to look at is if you are putting this into a house that you're going to resell in the near future, get a realtor that is certified for green energy components in the house. They can actually help you determine what the value of the house is once you install high efficiency systems into the house. When you're talking about windows, heating systems, whatever it is, the drain water heat recovery system also adds to that. It reduces your HERS rating by, as we mentioned before, 1 to 4 points. Here's an example of a typical household of 4. Hot water set at 120, let's see, typical for a family of 4, you're using about 120 gallons of hot water per day. That's between showers, washing, bathing, all the hot water you're using throughout the year or throughout the day. Typically, that's about 35 gallons per person. Hot water set point, 120 degrees. Wastewater temperature, 100 degrees. Groundwater temperature, about 55 degrees. All typical numbers from across the United States. And the freshwater temperature of this particular example will be about 77 degrees. And the efficiency rating for the system is, for this particular system, is about 50%. So anyhow, when you get down to it, the nuts and bolts. Typical installation is about $1,000. That's between the unit and the installation. It may be more, maybe less. Just depends on what your typical situation is. Now, here are the numbers. Natural gas, which is a lot more or a lot less expensive. 6.6 years. For electricity at 13 cents per kilowatt hour will be 2.3 years. So you can see how the range works on that. But anyhow, it shows what the payback period is. Hotels use a lot of hot water. So in this particular application, depending on how you're using it and what your fuel cost is, you're looking at between a half a year and 4 years on the payback for your installation. Again, immediately reduces your operational costs, instantly increases your water heating capacity. And again, here's an example of how we base those numbers. Again, so hot water usage for the hotel. That number's not right. But anyhow, hot water usage per day at 30 gallons per person is 11,000 gallons per day. But anyhow, get down to it. Installation cost for this particular example, about $20,000. Return on investment, half year to 1.5 years. So see how these, you could sell this to your customers. It instantly reduces their operational costs, so their day-to-day costs, go down right away. Restaurants and, big user of hot water, anywhere from 0.2 to 3 years. And again, that depends on how they're using the hot water. If you have any questions concerning these, contact us. Give us some numbers about your customer, and we'll actually run through and show you what the return on investment is based on the numbers that you give us. And again, I just want to point out one thing. This is a typical installation, but we mentioned earlier cooling walls. One of the problems with the restaurants is the hot water from the washing systems going into the drain systems at high temperatures. Here with the cooling wall in this particular application, we have drain water entering the sewage system at 74 degrees, which is a significant advantage, especially for the water going into the grease pits and into the septic systems. And again, we're using all that hot water to preheat the water going into the domestic system. And for this particular system, payback period is 3.6 years to 1.1 years. Actually, these numbers are reversed down there at the bottom. No, they're right. But anyhow, you can see how the payback periods work. And really, that's about as simple as it gets with all these systems. Here are some interesting links to go look at for anybody that's interested. As we've mentioned before, a lot of these systems have been tested or analyzed by like the Department of Energy and a lot of other systems. These are standards that are being installed, like for the Corps of Engineers. They actually have them specified for all new barracks. We're trying to work with them right now to actually make sure that these actually get into all new construction. One of the biggest problems we have is many of the contractors out there have no idea these systems exist, or they don't know where to get them. But we're trying to cure that problem. But anyhow, like I said, there's some interesting links to look at. The Goon website on top, that's actually a customer that has been very interested in using this system for a number of years. And you can see how he's installed that in his particular application. So that's where we are. Mark?
We do have some questions.
Okay.
The first one came from Harvey Raymer. And he says, do the drain waste exchangers work better in a vertical or a horizontal position? And how are you keeping them clean for optimized heat transfer?
Excellent question. Actually, they will work in both situations, but I will say this. They are designed to work in the vertical position. And the simple reason for that is the technical name for these types of heat exchangers is a GFX, gravity flow exchange. And what happens is the water going down the drain pipe, the surface tension of the water tends to make the water cling to the surfaces, the outside surfaces. So you have maximum surface contact of the water on the drain pipe in a vertical position. Now, if you put it on the side, it will work, but the efficiency of the unit will be significantly reduced. So in a vertical system, say, for an example, you got a 50% recovery efficiency on the system. If you put it anywhere off of vertical, the efficiency will dramatically reduce to maybe, say for an example, from 50% down to 5 to 10%. And that may be acceptable depending on your situation. For some of our customers that we've talked to where they have limited space, but very, very high energy cost, they're willing to accept that type of reduction in efficiency. So again, they will work in either position, but they're designed to work in the vertical position. And as far as cleaning, the DWV is self-cleaning. So there are no surfaces on the inside for any contamination to build up on. I will say that basically, if you're running a lot of grease down there, especially with cold water, you'll have the same amount of buildup on there as you would with the rest of your plumbing. So there's no significant change between the water going down there versus any part of your plumbing system. So anything that washes down through there should go straight through. Technically speaking, we can make the units much more efficient if we put fins or increase the surface area through extra surfaces on the inside. But dealing with gray and black water, you can't do that because you have a risk of buildup on the inside. So
you don't want to go there.
The surface.
Yeah.
Yeah.
Actually, Mark, I wanted to add that there have been some attempts, and we are currently working on this as well, for a fully functional, clean, horizontal application. The ones that have been presented to the market, I know of one that I've looked at out of Europe, and it was a snake-style horizontal. The problem that they had, they're out of business now, is they were getting a lot of hair, skin, soap scum, things like that go into they mounted them and installed them directly under a shower. So for every shower that you had to have one of these units. The unit itself was, I want to say, priced somewhere between $200 and $300. The efficiency ratings on them, they had them at 25%, but after testing and looking at them, they were probably closer to 14%. But the biggest problem they had is they were a PVC product that had water sitting in them, deterioration, leaking, and clogging. So it has not been perfected yet, and even on a horizontal, you normally have a pitch of, 1 inch for every 10 feet? Is that correct?
Quarter inch per foot, I believe, is the minimum. Right.
Okay. So you're talking about something that the vertical obviously is going to be the most efficient, but that's also what helps it be cleaning, self-cleaning with all the materials that go down there.
Sure. Okay. Hang on, I've got another question coming up here. And this one is actually from Adam Hill, who's an inspector up in Canada. And he said that he'd run into a situation where they had a number of parallel units that were actually in a gravity installation instead of using a pump force situation.
Mm-hmm.
He said the inspectors kind of raised their eyebrows at it, but they eventually passed it because it was an engineered system, which may be the answer to your situations. But I don't know. This is one of those areas that we're going to have to do some testing and education on of the inspectors to prove to them that this will work. But in my mind's eye, when I look at, say, as an example, 4 parallel units, and even if you're not using approved drainage fittings, if you've got 4 units in parallel and the flow is coming from the left and flowing to the right coming in, and on the bottom of the heat exchanger on the waste side, it would be starting from the left and going to the right. And that bottom side would always obviously be combination Y and H bend fittings that would be flow directing. But on the top of that system, even if you were using sanitary tees, the natural tendency for water is to follow the path of least resistance. Mm-hmm. So as the water is flowing into that heat exchanger, unless you had some really unique method of being able to set up parallel, like using what we call a pyramidic installation as opposed to a parallel reverse return, the majority of the drain water is going to flow through that first unit, and the second and the third and the fourth unit would probably see little to no flow on the drain side at all. But this is the kind of stuff that's just going to take some time to do some research and development on and testing and come up with a methodology that says, here's the best way to do it, and yeah, it doesn't meet code, but code didn't know about drain waste heat recovery when these fittings were invented.
Sure.
It's one of those things that will work out.
Yeah, Adam and Mark, a couple things that we've seen is when you do a parallel system, we sometimes, radiation or not radiation, but the parallel installation manifolds. Almost every application that we've been involved in as far as supplying, there's been a pump system, be it the laundry or the restaurants or the water parks. There was always a pump system, the gyms as well. And that, like you said, part of that has to do with the flow, and you also have to worry about your pressure drop on your incoming water. You're going to have a lot of pressure drop, especially if it's only on a half-inch coil run in a manifold. That's one of the reasons why we went to the new design of the 3/4, so that we have less than 2 psi drop per pipe. Mm-hmm. So that's one of the things you have to look at, and the things that we'll be testing and have monitored as well. So as an inspector, I know that they had a problem. There was a company that was selling heat exchangers, 1G model, which was a single pipe, single coil wrap with half-inch, saying it would handle a whole house, and they were having a lot of pressure drop, about 8 to 10 psi in the homes, and there was a problem with that, and the inspector said no more of this. One of the reasons why Carmine, originally the original designer, designed the S model was because they weren't able to bend at the time efficiently or effectively the 3/4 tubing. Mm-hmm. So he went with the S model, which was a split coil system to basically address the pressure drop.
Sure.
And so now the 3/4 model, actually we use less copper on the Y model than the S model. Less copper, less weight, less labor to put them together. So we're trying to bring the cost down, keep our efficiency, and the very low pressure drop.
Excellent. Adam came back with another question. He said, if you had a dedicated 2-inch stack for showers and bathtubs, or if you were designing this into a new build, wouldn't a drain waste heat recovery of 2-inch size give you better heat transfer than a 3-inch?
Actually, Adam, when you use a 2-inch, we have to go in the wrapping tube to a 3/8. So you have to go to an S model 2-inch with 3/8 tubing to make half-inch water pressure. So 3/8 and 3/8 split coil equals a half-inch, which a lot of times is, for some applications, acceptable. In most cases, it's not. But the more surface that you have, and think about when water goes down a sink. It normally starts out and it's wide and it's circling down, draining into that 1.5-inch drain. But when it gets back out, it goes back out to the widest side that it can. That's just the characteristics of that drain water. So the 4-inch units are actually have been tested, and we have found to be the highest efficiency rating for whatever length you're talking. If you're putting a 48-inch 2-inch versus a 48-inch 3-inch versus a 48-inch 4-inch, the highest efficiency is going to be in that 4-inch tube.
A larger surface exchange area, basically.
Exactly.
Okay. Well, I don't see any other questions in here, so I would like to thank our attendees for those excellent questions, and also thank our guests for their excellent presentation.
I also thank you so much, Mark, for having us on today. Just real quick, we have a tremendous amount of information on our website, which is www.swing-green.com. Swing-green.com. We have everything from energy efficiency to Department of Energy to testing. Give us a call if you have any questions.
Yeah, absolutely. And if you've got any unique installations like numerous parallel units, whatever, call these guys. I'm sure they've got enough experience to the point where they can get you through. And if they ever come up with a question that they can't answer, they can always ask me. And if I don't have the answer, I'll find someone that does.
Mark, everybody, thanks again for having us on. It's been a great morning.
You bet. Thank you. And real quickly, now that we're near to the end of the show, I've taken back over control of the screen, and I am going to share my desktop, and I'm going to show the video that I put together showing folks how to actually utilize these tools that I've developed for being able to increase your efficiency. So here it is. This is RPA's tip of the week, and there it is. That is a Ryobi 10 1/4 inch cutoff saw, just a typical wood cutting saw that I put a fine-toothed carbide blade on. So I'm cutting 6-inch, 1-inch copper nipples, and anybody that's ever done this by hand can really appreciate how quick this is happening. Zing, zing, zing. By the way, full ear protection, full eye protection, and full face protection, because this thing is spitting little pieces of copper at terminal velocity. All right, so they're cut. And we still got to clean them, and technically you still have to ream them. So I grabbed myself a little Delta 1-inch band saw, or it's actually a band sander, belt sander. It's 1 inch wide, and took the platen off the back of it so that I can actually flex the belt. And as you can see from the dust, it's been a long time since I've used it. Saw that ream that was on the inside. So what I'm doing is I take a tool and I slip it inside of the pipe and push it against that band and allow it to slip in my hand. And it spins it around and cleans it up, and it actually etches the copper and puts a real light scratch pattern into the surface of the copper itself, which ends up holding solder and flux much, much better. Mm-hmm. So you zip through these puppies real quick, and normally when I'm doing work in the field, I set up a full table. I've got an 8-foot table set up with my cutters and my sanders and my fluxers and all that stuff, and I blow through this stuff like nothing. And most other plumbing contractors that are on a job site watching me work are like, wow, that's fast. Why didn't I think of that? What I'm doing when I put that nipple actually into the face of the belt is there's a little bit of a jagged edge that's left over from when it comes off of the chop saw, and it takes that burr off of there instantly. All right, so get rid of the burr, slip the tool inside, let it slip in my hand against the belt, and then flip it around and finish the other side. And at that point, I'm done. Ta-da! Nice, neat, nice, clean. You can see the little bit of the grain that it actually puts into the copper that helps hold flux and solder. Mm-hmm. I mean, just about now, I'd probably be getting close to finish cutting by hand.
That's just too easy.
Yeah, it is. You know, and that's the great thing about power tools is that if you utilize them to your advantage, it is a godsend. It can save you a whole lot of time and trouble in putting these things together.
You're supposed to sweat, though.
Yeah. I noticed you're not one of those contractors like I used to be that runs around without a shirt and stuff just hits you like bacon, you know, frying bacon without a shirt on.
Well, actually, I did these shots yesterday, and it was kind of cool out in my backyard, so I didn't want to be exposing myself to too much solar radiation. I've had myself exposed to plenty of radiation as it is already. Would like to thank you guys for taking time out of your busy Saturday schedule to come in here and show us what it is that's going on in the way of drain heat recovery. I don't see any new questions in our Q&A box, so I assume that there are no questions anybody wants to ask openly here in this public forum that we might possibly be able to help them with. But
well, they can call us if they need to. Sure. We have a toll-free number. It's 855-439-7446. Kurt's extension is 101, and my extension is 102.
So if you have any questions, just give us a call. We'll walk you through it, and we're more than willing to help you out with any type of questions or situations that you have.
Excellent.
And we're all just going to go green in 15, right?
Absolutely.
All right.
You guys have a great day. At all. Our next folks that are going to be coming up 2 weeks from now, we will not hold a hydronic talk because it will be December 27th, and I intend to be at my mountain home enjoying the beautiful scenes and relaxing and maybe even walking on ice if it's finally set by then. And our next show will be on January 10th at 12 noon. when Dan Holohan is going to be our guest interviewee, and rumor has it that Dan is retiring. Dan has been doing this forever, and met with him up in Canada when I was up there at a conference recently, and he said, I noticed something in my grandkids that very few people notice because they don't look at them close enough, but he said every one of them has a little tag on them that says, best if used by, and there's an expiration date on there, and he says, by God, I'm not going to let that expiration date pass, so I'm going off the road. He said he's going to write until they close the casket, but he's no longer going to be doing any of his road shows. So if you have any questions that you would like to ask Dan, by all means, show up January 10th at noon and listen in, and he will fill you in on what is going on in his life and answer any questions that anybody may have. So with that, thank you all very much for your time and attention, and that ends this session of Hydronic Talk, and we'll catch you all in about a month.
Outstanding. Thank you for having us.
Travel safe, and we'll talk to you all later.